Okay, so this is a re-recording of the point clouds from Photos webcast. We had some difficulties with the recording done on the day. My name is Sean Twomey. I'm the ANZ Consulting Manager for A2K Technologies. My background is civil engineering and survey GIS, so this concept of doing reality capture and building models to put in space is something that's very relevant to my background. So what we've got here is an agenda where we're going to discuss some software. So recap is the main package, stands for reality capture. There's two main kind of angles on this. One is the version that uses the laser survey, which is quite a familiar concept. The other is using photogrammetry, where you take 2D photos and build models from those. That's newer to most people. It's been around for quite some time, but the software hasn't really been powerful enough, or the hardware also has not been powerful enough to make it work well. So it's not that difficult to use. The main kind of focus is on the tips and tricks from the photography side, and we'll then show some general examples, including how you can actually use it to do an intersection. Then we'll briefly mention some of the limitations of what it doesn't do. So let's get into this. On the bottom right of the screen, what you see is a standard recap model. So this is inside in the Revit engine. The model was generated from a laser survey, so this is one of the more familiar areas. Revit 2014 will let you spin this around in real time, so you can then go and draw new geometry based off the point cloud survey. Now, what we're doing effectively with recap is building the point cloud from photographs. Now, the concept of this has been already published in 123D Catch, which many of you will have seen. So we've got a video here on the top right, which is going to show how this works. So effectively a bunch of photos get taken and a model gets formed from it. So it can be somebody's head, which can then be 3D printed, or it can be a building, or it can be anything really. Now most people do this with the iPhones, so you use the iPhone camera, you build a pretty respectable model from that. What recap effectively is the same concept but done to a higher standard. So you have higher resolution photographs, you have more of the photographs, and you have a higher resolution mesh being produced from it. And you can then download various files to put into your packages to do engineering production work. So the 123D Catch version is not too far off that, to be honest. You can do quite a lot with it. I don't know if you would really want to put it into full production work. So the website is there, 123dapp.com. So Catch is one of the packages. There's a full family of them. So if you haven't gone there, they're well worth looking at. Now what we've got here on the bottom right is a video of a point cloud produced from recap photo. So this was produced from 2D photographs. The photos were taken in the air by using a drone, so they were mounted on this kind of quadcopter device, which gave the benefit of having nice good angles facing down on the terrain. What that meant as well is that extra geometry was picked up, like the buildings in the background and the roads and the trees, etc. So you end up with a very comprehensive model that can really give you a good picture of the whole infrastructure. So that's an example that was given to us from Autodesk. What we did once we got the software was produced our own model. So there's a church just behind our office here, which we went out, took some photographs of at lunchtime, uploaded those, and were very pleasantly surprised with how good the model came out. So in this area, I'll just pause it, you can see the feature on the church. The photographs were taken from the ground, and I was able to pick up this level of detail. So if we set the actual point display resolution down, the finer mesh, you can see the quality of what is picked up. Now we're showing it here color coded by elevation, just to emphasize that it's not just a photograph, it's actually a set of point clouds that can be rendered from different kind of perspectives. You can also see that it's picked up individual brickwork, so the quality of the mesh is very, very good. And the most important point to emphasize is that all these photos were taken from the ground. So producing this plan view that we see here is something the software allows you to do because it produces the full model for you. So that was something we were very impressed with, and it effectively proved to us that the software is real, so we did more with it from that. So the next thing we picked up was a larger building. So let me just go back to here, get into it. There we go. So this is the hotel next to the work office. So this is inside and recap on the desktop application, and what this lets you do is view the point cloud in real time. So as you can see, we're able to spin around here. It's picked up, this is actually the hotel, which has picked up the front of it, the lamppost, everything else, and given us a bunch of information to start doing a model with. That can then be put into Civil, Revit, whatever package is needed to change around the work with. So again, that's just taking a less kind of fancy building, because as the software picks up a church, it's got lots of features to overlap and work with. This is not quite so standard building. It's also got reflective surfaces, which aren't ideal, but it still managed to pick up everything for us. So what that does is it shows us that the software does work, and the next question is how you use it. So it fits into most of the packages that you're going to use. So it goes into AutoCAD, Navis, Revit, Inventor, InfraWorks, Civil, Map and Plant. It's also coming into 3D Max. So the procedure for using it is that you take a bunch of photographs, you decide on what resolution you want to use, etc. We'll talk a little bit in a while about the procedure for taking those photographs. You upload those to the cloud and you let the process run by itself. So you don't have to do all that much in terms of interaction. When it's ready, you get an email notifying you of the fact that the mesh has been created. You can view that on your desktop or on your mobile devices, and then you can add more photographs to it and refine the process, or go and download the point cloud. So in terms of how that looks for using the software, the left hand side of the screen shows you the Autodesk 360 view. So you create a folder and upload the files. Now in this case the files are quite large. We used a full frame camera, so they were 16-17 megs each. That takes a long time to upload, so you may choose to resize those for the first pass just to kind of get the process working quickly. The screen on the right is the option you get then. So you give your project a name, and the main thing you do is go to the mesh quality. You've got the option to pick a low res mesh of draft, or standard, or a very high res. So I usually include the draft version as well, so that you will quickly get an email which will give you a very kind of a rough view of what's happening, but it will be enough to confirm that you've taken enough photographs. So if that doesn't show up properly, you know you might have to go back and take some more. There's also the option up here on the top right for registration. What that will let you do is pick known points in the photographs and type in coordinates. So on the bottom left you can see the XYZ coordinates. That will allow the software to orientate the point cloud in the correct space and scale. You could also type in distances between those coordinates, so it can just do the scale options. Now when I tried this initially, I didn't get it to work too well, mainly because I didn't have accurate coordinates available for the surveys I was doing. So what I just did was left it at arbitrary coordinates. I brought the mesh into CAD and used the CAD commands to orientate and scale the mesh correctly, and then I was able to work on it normally. So on the left here is the email that you get. So it just gives you a kind of an update that your mesh has been created. On the right is the web viewer, which basically lets you spin your model around online and confirm everything is correct on it. It shows you the photographs that have been used on the left hand side of that view, just holding the mouse over it now. If some photographs could not be stitched, it would highlight those as well and let you decide what to do with them. So you can remove them, or you can pick them manually and try to convince the software which points should correlate. So the main kind of art form of this is taking the photographs correctly. So the rules are you must have a lot of overlap. So you want to take a bunch of shots of the same geometry and make sure you're not standing in the same place. You must move, so each shot comes from a different angle and lets the software triangulate. Now, it can't work if the photographs are not in focus. So for those of you who've done photography, you're familiar with the narrow aperture concept. By having the aperture narrow, it means that the background and the foreground are both in focus. This is critical for a recap, because if the background is blurry, it won't be able to identify points in the multiple photographs and mesh them together. So you will be able to use a tripod if you want to increase that. You also want to make sure there aren't too many shadows happening. So if you take the shots on a very bright day, and especially if you take them at different times on that day, the shadows will move, and when the software is trying to correlate the images, it will become confused. The same thing happens if you have too much movement. So if cars are in different positions on different photographs, or if people are moving around, as the software looks at the different photographs and tries to match them together, that will just confuse the process. So the ideal scenario is a slightly overcast day, so the shadows aren't too severe, early in the morning, so it's not too crowded, and you can quickly take like 50 or 100 photographs in 15 minutes and then upload them, and really that's most of what you have to do. So let's just do some examples here. The church was obviously the most obvious one to look at initially, because it's got a lot of features and we tend to see architectural work usually on this. What I've got here is Tamarama Beach. So this was just taken, I held the camera in my hand and just took shots as I was walking along one side of it. So what it's done is it's picked up the beach area and the green area in front of it. So what we could do here is bring this into some software, remove the existing trees and buildings down here, and build a concept of new facilities with swings, slides and children's play areas, etc., and show how it would look in context. And what's impressive with this is that you can do that quite quickly and quite cheaply in terms of visualizing it, and then position the camera wherever you need to show how it would look. So this was done literally while walking past, just taking some random quick photographs. So what this is doing is showing that recap photo can be used not just for buildings but for infrastructure jobs as well. So that's one example which positions that. The other one is this is a roundabout. This one's in Maroubra. Again, this was taken early in the morning, and there are some shadows you can see, but it seemed to manage them pretty okay. It was nice and quiet. We didn't have too many cars and people going past. So all we actually did here was stand on the curbs and take photographs of the roundabout island at a tangent to the curve, and then just walk around and take shots every couple of feet. And then we did the same thing in the opposite direction. So I think we took about 120 photographs of this in high res, uploaded them, and we were very impressed with the fact that we can then get a plan view. So all these photographs are taken from the ground, but you end up with a full model that you can work with. Now we haven't had a chance yet to verify these against a standard survey, but what's impressive is that you pick up the curbs, the gutters, the details of all the furniture. So I think what you would do is still perform the standard survey for the strings and use this to add extra detail to it, because it picks up information that you can't possibly get on a survey. So that is the roundabout example. What we then wanted to do was take this and apply it to an area that we could redesign. So we know of this 5-way intersection quite close to the office, where effectively there's 5 roads coming together in a way which is quite interesting. So what it could do with is a roundabout to help the traffic move around. So this was about 150 photographs taken. Now the we didn't have a roundabout to focus on to correlate them, so we just took the shots on where we assumed the roundabout would be. So we effectively worked around that junction in a circle, taking shots towards the centre and a few angles, and uploaded to the cloud and got this, which is a pretty good mesh in itself. The next thing we did was put that into some software and design a roundabout on it. Now, we're not going to go into the details of that too much, but this is the result. So this is the exact same mesh. We've removed the triangulation from the areas where the roundabout was going to go. We formed a surface model from the mesh and designed this roundabout into it. Now this was more of a kind of a conceptual design. We didn't actually have a real survey to check anything with. What we're doing here is just proving that we can take the point cloud and do a kind of a concept. So we can show effectively that to do this you have to take over a certain amount of the curves, take over a certain amount of green areas, etc., etc., and just make sure everyone's happy with that. So what we've got here is the actual point cloud that we downloaded. So we'll just show a little bit about how you will remove the areas that you don't want from this. This was the original survey of that area, of that five-way junction. Now on the last version I showed with the roundabout, we had effectively frozen the points in the central area. So what you do with this software is you've got a selection option. So I'll pick fence. Now I'll do this in two different ways. One is where I draw a very rough circle here. I'll highlight a bunch of points, and I've got the option to delete these points. So that's one way of doing it. It's not the best way because you don't have much control over the points afterwards. Another option is to pick the same kind of criteria. So I'll do a very rough shape again. This time, instead of deleting the points, I'll put them onto a new region. Now, a region is very similar to a layer concept in CAD. So on the bottom right of the screen, I've got my regions dialog box. So if I go to my scan regions, region 01 is here. I could change the color. In this case, I'll hide the region. So it's a very similar concept to turning layers on and off. So once you've done that, what you can do is export just what's currently visible as a separate mesh and work off that. So you would carefully remove what you don't want. The same applies to these white areas up here. So as you take photographs from the ground, you pick up areas that you don't want. So for these areas, I would actually erase them. You would select these, press delete, and just, it's a matter of how diligent you want to be in terms of visualizations. So you would delete those. What you could also do is take these trees, because they can sometimes block your view. You probably wouldn't want to erase those necessarily, but you could take those and put them onto a new region. So effectively you could freeze those afterwards using AutoCAD language. So I'll go here and hide that tree, which means that when I come and look from here, the tree isn't blocking my view. So that's a very, very quick view of what you would do with the desktop application, just to kind of refine your mesh. You can also combine different surveys here, so you can use this thing to build up the model and then take it into your design engine and process it. Now, we're not going to go into the details of this just here, but what we've got, we do have the design open here in Civil 3D, so I can find that. This was the actual point cloud downloaded. We traced some of the lines and drew some of the mesh, and we then designed the roundabout using this. That could be done in any design package you want. So we can share this information if you want to get a copy of the file, but really that can be 12D, MX, whatever you happen to prefer for your designs. So the last thing we did with this was push it into InfoWorks. So that's the roundabout design inside an InfoWorks, and we've got some line markings, and we put on a palm tree just to be artistic as well. So you can play with the settings to show the shadows and everything else. What you can also do is put this onto your iPad and walk on site and see how this will look using augmented reality. So all you actually do is hold the iPad up and turn on the camera view and leave the GPS and orientation position the angles properly. The parts you have to be careful with on this are that the GPS of the iPad is not that accurate, so you may need something else to improve that. Once you get that in place, you can go and show exactly how this will look on site. So from a planning perspective, taking a nice quick survey showing first of all that the design is feasible in terms of fitting the roundabout into the space, and then taking that design on site to confirm with various people that they're happy with the concept is a pretty powerful engine. So the last thing we've got here is a large survey coming into InfoWorks. So in this case, it's one of the examples auditors have given us, and what you're doing is you've built up an InfoWorks model with the aerial photography and terrain models, and you can now deposit a huge point cloud into that. And once that's come in, you can go and start designing new features based off your geometry. So this adds a huge level of reality to your design process. And again, it's just done by photographs, which is the part which still fascinates us. So you could take this and pick your areas of interest, design them, and show exactly how they will look in the real world. So the limitations really are that you must be careful with your conditions. If there's too many moving objects, you really don't expect it to work that well, and you want the light conditions to be consistent. You also need to be careful with the photographs and make sure everything's in focus with a narrow aperture. Then the other thing is that you really do need an old-fashioned survey as well to orientate your point cloud into known coordinates. So I don't think it's going to replace survey. I think it's going to supplement survey and add extra information, extra kind of organic material that you wouldn't pick up normally to help improve your design. So really, once you bear those in mind, there's not much stopping you from trying it out. So as long as you've got a 360 account, all you have to do is log into that, upload photographs, and see how it works. We're very happy to help out with some of this process, so leave us know how it goes, and we'll come advise and work with you. We do have more webcasts coming up, so best thing to do is go to our website and press the events tab. It will show you all the events in general and webcasts. So we've got a few follow-ons from this using architecture models and Recap Pro. So with that, I'll sign off and look forward to hearing more details of how you've gone.